You all can see this? Cool. Okay. So, hi everyone. My name is Haoyi, and this presentation will be about the com.lihaoyi ecosystem. Executable Scala pseudocode that's easy, boring, and fast. So, a bit about myself. I've been using Scala since 2012, and I work on the Databricks developer platform. So I've done a bunch of open source Scala work, Scala.js, Mill, Ammonite, blah, and I'm author of the book Hands-on Scala Programming. So the agenda for today is we'll have 4 sections for this talk. One is we'll have a quick overview of what the com.lihaoyi ecosystem is, what the com.lihaoyi ecosystem is not, what are the principles behind this ecosystem of libraries and tools, and we'll do a case study of the Mill build tool, which is the build tool used for all of these libraries. So to begin with, what is the com.lihaoyi ecosystem? So the com.lihaoyi ecosystem is this group of libraries and tools I've been working on more or less for the past decade. So starting from Scala tags up in 2012, all the way until like my argument parsing library down in 2020. And they basically cover all the common things that you probably want to do at some point if you're doing any sort of software engineering work. So things like data serialization, things like reading and writing files, things like making RPCs like HTTP or serving HTTP, and so on. So these are all currently under the com.lihaoyi GitHub organization. Moved there from my personal GitHub since now with other maintainers. And these guys have also been a great help keeping the libraries up to date and pushing them forward. We get about 17, 18 million downloads a month from Maven Central. So this is probably not as big as some of the other more glamorous or more well-known high-profile ecosystems, but it's a good amount of usage and people are using them out in the wild. Lastly, this is largely a self-contained ecosystem. So you see those libraries there on the left. They all depend on each other and they generally do not depend on anything else. So you're not going to dig into your HTTP server and suddenly find a huge like Akka backend under the covers. Or you're not going to dig into your JSON library and find there's a huge like type-level thing there. All of it lives within these relatively small number of relatively small projects. So this makes it a great way to learn Scala because the amount of things you might need to learn is bounded. But also if you want to use a JSON library that doesn't have any opinions on what ecosystem you're coming from, whether you're using Akka, whether you're HTTP4S or something, like all these tools are pretty much agnostic to what framework or ecosystem you're coming from. So I'll go through a short tour of all these libraries. You have the Scala tags HTML library that you write some nested function calls, turns into HTML. You have the fast parser combinators, like the Scala parser combinators, but 300 times faster. You have the utest library, which is like a small library for writing and running unit tests. Upickle is a small JSON binary serialization library. Ammonite's a nice REPL. So this lets you do multi-line editing with nice syntax highlighting, as well as multi-line outputs. You can see over here, this full case class got nicely formatted over multiple lines when necessary, collapse onto one line when not necessary, and generally all nicely syntax highlighted for you to see and use. You have source code, which lets you get like implicits for line numbers and file names. Very useful for things like logging messages. So you can see where in your code base a logging message came from, rather than having to grab for strings all the time. You have the Mill build tool, which lets you write objects and traits and methods, and it helps you build your code without having to learn any special magic. The pretty print library, which is a pretty print extracted from Ammonite's output. So if you want to put pretty printing in your own logging, or when you're own debugging on the pretty print things rather than having it black and white and like going back and forth across your terminal, you can use pretty print, and you can see it has nice, yellow, green, quite nicely formatted output. OSLib makes it very easy to read and write files and work with subprocesses. Request Scala makes it very easy to make HTTP requests, and Cask makes it very easy to define HTTP endpoints other people can make requests to. It's like a micro framework based on the Flask project and from Python. And the main Args library is probably the most recent one from 3 years ago. That is, you just take any method, tag it with @main, and you have a main method which takes flags, has default arguments, has a help message, and so on. So does any of you, who here uses any of these libraries? Anyone? Okay, so all of you use something. Probably none of you use all of them, but most of you use some of them. So we've gone through like a lightning tour of what all these libraries are, and you may have started seeing some patterns among them. But let's go into a bit more detail about what these libraries are not. So like one thing I've heard are these libraries just for people who want to write Python but can't? And the answer is half yes. Because your upickle is like the pickle library from Python just with a U and in Scala. Ammonite is literally the IPython REPL just re-implemented in Scala. Pretty print is the pretty print library from Python, and request Scala is the request library from Python. And it's literally like method for method, class for class, copy paste, convert to Scala, and it's great. But on the other hand, some other libraries are not copy-paste from Python. So you're not going to find Scala tag style nested HTML construction in Python. You're not going to find parser combinators in Python. This example at the bottom where we have is from Mill. You define a module by using the stackable trait pattern to say object extends, and these kind of stack together to define exactly what you want by mixing in all these traits. So all of this is technically possible in Python. Python does support nested function calls and operator overloading and multiple inheritance, but it's not Pythonic, and all of these libraries are not something you would see in the Python ecosystem. So is it about Scala.js? That's another question I've been asked, because at the time I was very into Scala.js when I started working with Scala. And at the start, this was largely about Scala.js, in that Scala.js had no ecosystem, like zero. There were no libraries. You had a compiler. And for the longest time, the only way you could serialize something in Scala.js was by using upickle. There was nothing else. And you could only test things using utest. You could only generate HTML using Scala tags. But it's since kind of drifted away from that. And most of the more recent libraries do not benefit from or even support Scala.js. Like Ammonite REPL is JVM only. Mill is a JVM project. OSLib files and sub-processes don't exist in Scala.js. So, and furthermore, Scala.js itself has also matured. So the people using Scala.js can have their pick of Scala libraries to use. They can use Cats, they can use Circe, they can use whatever they like. Everything supports Scala.js nowadays. So while initially it was very much like a Scala.js thing, it is no longer, not since 2014, which is almost a decade ago. So we've gone through a quick tour of what the ecosystem is and now what the ecosystem is not. So maybe the next thing is we're going to go through some of the principles that kind of underlie all these libraries. And what's a common thread that holds everything together? Like, why are these libraries different from any other libraries that some other random people may be putting on the internet? So the kind of one-line explanation is the com.lihaoyi ecosystem is about using Scala as executable pseudocode that's easy, boring, and fast. So that's like a pithy one-line statement, but each of these things has words, has meaning to it, and I'll break them down. And this is very different from many other ecosystems where the philosophy may be like performance at all costs or safety at all costs or maximizing this or the other. And for the com.lihaoyi ecosystem, this is what we are trying to maximize. And there's a few things here. First, executable Scala pseudocode. So everyone knows what pseudocode is. You write it on a whiteboard, you kind of give it on a piece of paper to your friend to explain what's going on. You write it in your notebook to try and debug some algorithm. You find on Wikipedia and try to translate it to your homework assignment. You all know what pseudocode is. And executable pseudocode means you can actually run it. Like, it's not just some random arrows and words you put on text, but you actually can paste in the program and run it without first translating into a real language. And when people think of executable pseudocode, they often think of Python. Like, everyone does interviews in Python. Like, everyone goes, why saw your breadth first search, your Dijkstra's algorithm, and so on. But when you think about it, Scala is in many ways as concise as Python, if not more. It's better at executing bit, like executes faster, executes safer. It's easy to deploy somewhere to execute without dealing with your pip errors or whatever. So why don't people use Scala as executable pseudocode? So to take an example, imagine you're interviewing. Let's say you got laid off or you're looking for the job market and you're in a room with some random interviewer from some random company that might not even speak the same programming language. And he asks you or she asks you to write a web crawler or a GitHub issue migrator or some other programming challenge. So you all go writing your breadth first search on the board, and at some point you're going to say, okay, I'm going to put a HTTP request here. And what do you write? So do you start off by importing things, importing a Scala DSL, defining multiple implicit actor system with behaviors and execution context extracted from the actor system, and then you import more DSLs for HTTP, which you then use to make a HTTP request, and then after that you import more stuff from Scala standard library so you can just use the output of the request that you just made. So you're probably not going to write all this on a whiteboard, and all of this, while necessary sometimes, is often not necessary much of the time. And maybe you want to deal with it later. Like later on, you want to optimize your thread pool. You want to make your thing async and to fiddle with how your actor system and throughput, concurrency, bottleneck throttling works. But initially, for many projects and for pseudocode, you don't want to care about all these implementation details. So if you're like me, you'd probably write something like this. How to make a GET request. How do you make a GET request? Well, I get.request or request.get. So okay, request.get. And then you put in the URL because you need to make it to a URL somehow. And then you get a response. And then you do something with it. So this is what the request Scala library lets you do. And you really can take this, paste it into your Ammonite REPL or your Scala REPL, and run it, and that's end of story. No translating it from your pseudocode on the whiteboard into like real code in your code base. Next example. Let's say you have an intern. Your intern just joined. Your intern's job is to make a command line tool. So you're sitting there with a piece of paper next to your intern's desk. You're trying to write out on a piece of paper, okay, this is what I want you to do. The command line tool has to take this, and had to do this. So what would you write? So would you create a case class defining the input to the command line tool? Seems reasonable, that's okay. Would you then define a builder that's a parser builder of your case class? And then you have a parser that's importing the builder using a different parser that's capital to do a whole bunch of stuff. That's kind of duplicated from the case class above, as you see, like the names are all duplicated, the field names are duplicated like 3 times, some are required, some are not. And would you then use a lowercase parser to equals uppercase parser dot parse of the parser again to then finally take the parse thing and then do what you want? So you probably won't do all of this. You probably will, this is like way too much stuff to use as pseudocode. And the thing is, it's all reasonable. Like this is all separation of concerns, functional combinator, builder pattern, error reporting, all that stuff. All that stuff is great, but it doesn't really serve a purpose as pseudocode. So you want to do this at some point, but you don't want to do it immediately at the start when you're sketching out like the skeleton of your program and trying to understand the algorithms and high-level data flows around it. So if you're like me, you'd probably write, I need to define something that someone's going to call from the command line that takes arguments. So what takes arguments? Methods take arguments, and you define them with def. Maybe call it run, maybe call it main. You say what you need to pass to it. Maybe it takes a string, an integer, and some kind of flag. And you use the things that you will pass to it. End of story. So this is, with a bit of annotation, is what the com.lihaoyi main args library lets you do. And this, although it takes a bit of annotation, I still have to pass the arguments, the real arguments from the command line in somehow. It handles a lot of this boilerplate on the left for you. So you can really focus on what you are trying to convey and what your program is trying to do, rather than focusing on all your mechanics of how you're meant to do it. So, in short, like this is kind of why Scala has traditionally not been good at executable pseudocode. The language is great. The language is really concise. And if you're making a linked list or a Fibonacci function on the whiteboard or a slide, it looks really good. And the time comes you actually have to do something with it. Like, I want to make a HTTP request. I want to parse some command line arguments. And suddenly it doesn't look so good anymore. If you look at these examples, they're actually not that much more verbose they're actually not much less verbose than using Java libraries. Like if you use argparse for J, or if you use Apache HTTP client, it would probably take just as many lines and just as much boilerplate as using these libraries like scop or Akka HTTP. So again, it's not because these are bad libraries. It's because these libraries kind of do not have go that last mile in order to turn well-engineered, well-separated concerns, designed patterns, production code to wrap it up nicely so it can be used as executable pseudocode. So the com.lihaoyi libraries do that. They internally, they have all this stuff inside. They also have builder patterns. They also have functional combinators. They also have config objects. But we wrap them up nicely, put a ribbon on them, and they all look very similar. You have method definitions, maybe some annotations for some metadata. You have method calls that do things. So if you're defining something for someone else to call you, well, it's a method call. If you're calling someone else, it's also a method call. If you're defining something, it's a method definition. If you're calling someone, it's a method call. And whether it's a HTTP endpoint that you define that takes arguments or a command line endpoint, in the end, they're just methods with different argument passing logic. Similarly, if you're making a HTTP call going out to the internet or making a command line call to someone else's main method, you're also just making a method call with maybe different formats of arguments. So maybe one more thing I want to mention is all of these libraries have all the design patterns inside, and they do expose the more detailed APIs if you want. So you can open up request.scala, get your config object, reuse your request object, reuse your session. You can open up Cask and override your HTTP handlers to add WebSockets or something unusual that the normal API doesn't provide. You can open up like uPickle and have all sorts of different backends, render to YAML, parse from YAML, that are not built into the default APIs. But the default APIs are great defaults. And for most people, maybe 90%, 99%, you can just use the default and be done with it. And the 1%, well, those guys can do the slightly more complicated thing and open up the library and use it in more detail. So that's the executable Scala pseudocode part, and that's what makes the com.lihaoyi library special among other platforms or frameworks. Next thing to look at is easy. So this word is very intentional. There's this meme going around like simple is not easy, blah, 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 simple is great. Kind of originated from the author of the Clojure programming language. And the idea is that simplicity is kind of this like inherent thing that's your whole system from top to bottom uses a small number of orthogonal concepts. And easy is more like your last mile polish, your familiarity, your onboarding documentation, and all these other things that are kind of separate from how simple the thing is. You can have a simple thing that's really poor docs and it's hard to use, or you can have an easy thing that is actually very complicated inside because it hides all the complexity inside of itself to be very easy and serve your use case. So simple is not easy. And like Martin Odelsky likes to say that Scala is very simple. It has a very small grammar. And in many ways, like, he's right? It is quite simple. But what's missing is easy. Like Scala is not easy. It's simple enough, but it's not easy. And that's what the com.lihaoyi ecosystem aims to give it. So let's consider some examples. Here's the snippet from like the fast-parse example JSON parser. Fast-parse parser combinators. It looks a bit weird if you don't know Scala, but it's not that different from standard library parser combinators, for example. So if you look here, a string is a quote followed by string characters or escapes, repeated, followed by another quote. An array is a square bracket followed by JSON expressions, repeated with comma separator, followed by a closing square bracket. And yeah, you have some extra like decoration. You have these like exclamation marks to capture things. You need to map it to some kind of data structure you want to use if you don't want to just pass it and throw it away. But overall, it more or less matches what your grammar is meant to look like with some unavoidable boilerplate. So looks great, right? Looks just like Scala parser combinators, cats parse, any other parser combinator library looks like this. And you can parse it and it gives you great error messages. For example, let's say you forgot to put an entry in this JSON array. You get a very nice message saying, hey, I found a square bracket. I expected an object array string, true, false, null, or number. And you didn't need to do any custom like error reporting. This is all done for free, more or less. So the inside of fast-parse is very complicated. And the right is the data structure that kind of underlies the whole parsing library. And one thing that is worth highlighting is there's a lot of mutable state here. So you can count how many vars there are over there, but it's a very large number. There's a lot of vars. The terminal messages, aggregate message, short message, they all sound the same, but they're subtly different. The last failure message, the failure stack, whether it's not success, how deep the logging is, what the current index is, what's a cut. So the fast-parse internals are not simple. They are very messy, convoluted, and honestly, it kind of sucks to work inside. Like, it's not great adding new functionality inside fast-parse. It's very confusing. You probably get it wrong a lot of times, and you probably won't know unless you have very extensive tests whether or not you're doing something bad, so to speak. But the point of all these mutable variables, especially the top 5 of them that sound almost the same, is to provide these really good error messages that someone can run your parser and tell you exactly where it's meant to fit, where it failed, and what it was expecting at that failure, while still having really good performance, like 300, 400 times faster than Scala parser combinators. So if you guys watched Daniel's talk yesterday about micro-optimization, fast-parse does all of that, as well as several more things which are actually very sketchy but turn out okay. And it works. So that's how fast-parse tries to make things simple for the user. Like as a user, you want to parse things, you want error messages, you want performance. You don't care how dirty the inside is as long as the error messages are always good, right? But for the person maintaining it, well, it's not great, but you write it once and then you kind of leave it there and it keeps working for a very long time. Next example. So this is revisiting the main args example earlier. You annotate a method with main. You need to call some parser for methods thing, and then it becomes a main method. You can pass in command line flags. You'll do error messages, help messages, and so on. So parser for the way this works is that parser for methods is a macro, and the macro will look at this. Well, this will include all the methods defined in this. It'll find the methods in main and expand the macro into something like this. This is slightly simplified, but not that simplified. So you have some parser for methods. Maybe it's more than one main method. Well, here it's only one. There's a main data that contains a name. It's run, contains some argument signatures, each with a different type. String, int, flag. They have their metadata about names and defaults. There's an invoke callback that ends up taking the already parsed arguments and passing them to the actual method you want to call. And then you just run out existing, takes this data structure, and then does the internal necessary things to end up parsing and calling your main method. So this isn't simple. This is actually very similar to what SCOP looks like inside. Like if you look at it, the stuff on the right and the stuff on the left is basically the same data structure, just spelled a bit differently. So main args is not any simpler than SCOPs. In fact, it's more complicated because you put this macro thing on top of it and does a bunch of weird macro expansions. But the whole point of this exercise is to make things easy, not just simple. And the thing on the left is very easy. Like you can just give it to anyone who might not know Scala, and they'll be like, yeah, I probably know what this does. This is a main method, it takes arguments, and you probably can guess how to call it from the command line with zero documentation and zero experimentation. So that's kind of what the com.lihaoyi ecosystem aims for with easy rather than simple. So a lot of libraries in Scala already do more or less the right thing, but they lack the wrapping paper and the ribbon to make it like really nice to give someone to use. And sure, you're going to have to open it later when they have more advanced use cases. But at the start, you want it to be really simple or really easy. And that's what the com.lihaoyi libraries aim for. So that's easy. Next thing is boring. So a lot of Scala projects have traditionally been extremely impressive or ambitious. And basically things like you're building a distributed compute architecture of the future, you're doing some novel functional programming paradigm, and making some DSL, or trying to publish some research paper of something that's never been done before on the face of this earth, pushing forward the boundaries of human knowledge. The com.lihaoyi libraries are not the same. There are things like, I can write JSON, hooray, I can make a HTTP request. So these are not things that you're going to give conference presentations about, or usually, and they're not things you're going to be able to write academic papers about. They're kind of things that you put in your build file and you forget. It's like, yeah, okay, I need a JSON library, I pass JSON, okay, next thing, what's next on my sprint planning list? Yeah, what's my next ticket? And that's kind of intentional. So one way I think about it is that the traditional Scala frameworks have been very much like cathedrals. So they're really big, they're really pretty and impressive. They don't really compose well. You can't like stick two cathedrals together and make a different cathedral that you want. And also the cathedrals are not always what you want. Like maybe I want a house, maybe I want a bridge. I can't cross a river on a cathedral. And yeah, so that's the problem, right? Like if I want super large scale, high performance, high concurrency, distributed cluster compute, well, I have Akka. If I want small scale stuff, well, it's not so convenient anymore, right? On the other hand, the com.lihaoyi projects are much more like bricks. They are meant to be place and forget. You're meant to be able to, not just that, but also meant to be able to assemble them. So you can use bricks to build your own house, and use bricks to repair your cathedral, maybe it needs to be reinforced under load. You can use bricks however you want. Brick doesn't care. The brick is spread to everyone. So, and that's kind of the point of the com.lihaoyi projects, right? Like you can use your JSON, you can use uPickle to write JSON to serialize data in your research paper project. You can use it to serialize JSON in your 10,000 QPS backend server. You can use it to serialize JSON in your GitHub issue migrator or web scraper. You can use Scala tags to render HTML in your Akka HTTP play backend, in your HTTP4S backend, or on your static site that you're building using Mill or something else. So all of these libraries are meant to be agnostic, and they're meant to be kind of friends with everybody. So we don't judge you what you're using, but why you're rendering HTML, or how you're rendering JSON, or what are you parsing. We just give you the tools, and each of them is pretty solid. It's pretty solid and does what it says on the box, and it doesn't do anything else. Like you can assemble it on your own to do whatever you want to do with it. So that's what makes the com.lihaoyi libraries boring. They're meant to be bricks, not cathedrals. The last thing to touch on is fast. So the com.lihaoyi libraries are meant to be fast, not the fastest. There'll always be someone faster who can run one more benchmark, who can bash one more bit to kind of minimize the overhead. But they are fast. The JVM is fast. People write large systems in Python and Ruby. Python and Ruby run 2 orders of magnitude slower than the JVM, and their system seems to work okay. So how can we justify our Scala on running a JVM to be slow? So here are some rough kind of benchmarks to give you an idea. So the bottom left is like the uPickle, one of the uPickle benchmarks from the JSON Scala libraries benchmark suite. And brown is, I'm not sure you can see the others, okay, you can't really see, but brown is uPickle, it's kind of okay. There's a few on top, there's some more below. But basically uPickle's maybe top 20, 30% among all the libraries that are benchmarked. It's not the top, but it's okay. It's up there. Writing a JSON parser with fast parse on the top right, you can see it's comparable to the handwritten parsers from other libraries. Again, it's not going to be the top, but it's okay. It's 160 parsers a second versus Scala parser combinator 0.9 parsers a second. That shows what happens if you don't care about performance at all. It actually becomes a problem. The bottom right is some HTML templating benchmarks. Scala tags somewhat faster in Scala XML, or twirl much faster in Scala back in the day. Some of these benchmarks are up to date, some are a bit old, but the basic idea is that it's not going to be the fastest, but should be fast enough. And if we want it to be fast, because fast is easy and fast is boring. So fast building blocks are what actually let you not care about performance. Like everyone wants to say, I don't care about performance, micro optimization is the root of all evil. And then your HTML templating library starts using 90% of your CPU, and suddenly that's not caring about performance again. So with fast parse, you can just not care about that. You can just use your normal fast parse parser, and you can use it for prototyping. You can take it to production. You don't need to use a Scala parser combinator parser and then realize halfway through, oh no, it's too slow, and then have to rewrite it in recursive descent. And it means that simpler codes can satisfy performance requirements. Like coming back to rendering HTML again, Scala tags renders HTML fast enough that you do not need your hierarchical HTML partial template caching system that some other frameworks have. You just render all your HTML every time. And if you render too much HTML, your browser will crash, but your server will be fine because fast parse is fast enough. And so it just moves it away from the problem zone, and it becomes not the problem, and not problems are easy. And being fast also gives robustness to just screwing up. Like sometimes you just do the wrong thing. Like let's say you start serving huge binary static blobs from your web server that's meant to be serving high QPS. Well, with com.lihaoyi libraries like Cask, it's actually okay. Like you can serve multi-gigabyte blobs while also taking API traffic, while also taking web traffic from multiple different places. And it doesn't crash. It kind of works okay, maybe gets slow. But the outcome is you end up with a roadmap item that says, please optimize static file serving by end of quarter. And you don't get like an emergency that you write a post-mortem report for. And lastly, as I mentioned before, you can go from prototype to production without a massive rewrite. Like it's very common to, hey, this libraries are great. Oh no, they're too slow, rewrite. Python is great, rewrite in C for production, or rewrite in Java for production. Scala parser combinators, I've tried to use them, then you end up rewriting it anyway because it's too slow, even though it's very nice to use. In com.lihaoyi libraries, you generally don't need to do that. You take it, write it once, slowly evolve it until it's in prod. So that's fast, and that's it for the principles of com.lihaoyi ecosystem. Executable Scala pseudocode that's easy, boring, and fast. The last thing I'm going to cover is a case study, kind of deep dive into the Mill build tool. So Mill is a new Scala build tool, where new means something like 6 years old by this point. It's not actually that new. It's pre-pandemic, so before the world changed. And it's one of the main alternatives to SBT these days for kind of small, medium companies. If you're a large company, you use Bazel or Pants or something. But if you're a small company, you probably can't invest in Bazel or Pants because of big overhead and it's complicated. And you can use Mill. All the com.lihaoyi projects use Mill. Scala CLI uses Mill, Corsair uses Mill, like it works. And people complain about SBT or Gradle or Maven. No one complains about Mill, like people like it. So why do people like this build tool? Like, okay, let's talk about that now. So Mill tries to be executable pseudocode. And you can kind of see it from this example on the left. If you're at the back, you can't see, you can come forward. There's a lot of code on these slides. So you have objects that extend traits or classes. You have method definitions. You have Scala doc. You have more method definitions. It's a bit of weirdness. Like, what's this T thing over here? That's a bit weird. Or like, why does this method need parentheses? Or this method needs, this line count needs parentheses and this one had no parentheses. So it's not perfect pseudocode, but it's more or less looks like an object with definitions that call each other. And you can override things and call super. You learned about that in like Java 101 20 years ago. So from this, you can, in this example, it defines a new line count, build target or task. It takes all the source files, sums up their lines as you'd expect, and then overrides the resources to create a new generated line count file, which includes a line count, and then appends it to your resource-like path. So if I have a source file like this, which prints out the line count when you run it, I can say mill foo.run, and line count will read this file. It'll be 10. The module will compile this file, and then it'll run this Xcode, and I'll say read this from the resources folder, and it'll say line count is 10. Not so exciting, but it's a bit of like a synthetic example. This shows you can define your own build targets. You You can override existing build targets. You can call super and call other build targets. And in the end, it does more. That's what you want. You can use mil show to inspect individual targets, like on the show foo.line count. This is the same foo.line count you'd use in Scala code to reference the foo.line count if you want to depend on it somewhere else. You can use mil inspect to get metadata, like this was on build.sc line 6. And this here's a Scala doc. It depends on foo.all source files. Well, I wonder which target foo.all source files is. Well, it's the same one you're referencing here. So this is how mil works, and it kind of is relatively straightforward. And I guess what you don't see here is all the things that it does for you that you probably want that you may not know about. It caches everything. So line count will not get recomputed if all source files doesn't change. If you don't edit it, it'll just use a cache version. You can parallelize it, throw threads at it to make it faster or slower. You can inspect it, which I've already kind of shown below. You can poke at the metadata from the command line. And all this without, you're not constructing your own in-memory data structure with a whole bunch of case classes. You're just writing code. And it's a bit weird code. There's these T's and these parentheses that are a bit unusual, but it's mostly just code. So maybe one thing you compare is equivalent SBT build. So ChatGPT helped me write this SBT build, and it got a few things wrong, but I think now it's mostly correct. And if you look at it, it's about the same conceptually. It contains all the same things. You also have a line count with some documentation. It's also an integer. You also can have a custom task. It depends on the source files from compile sources and read them all up. It also overrides the resources in order to write a temporary resource file, write a generated resource file, and then add it to your resource path and be using plus equals. So why do people complain about the thing on the right and they do not complain about the thing on the left? And the answer is the thing on the right, although it's all the same concepts as the thing on the left, and it's nominally in the same language as the thing on the left, all the concepts are kind of different. So instead of having a definition of line count equals something, you have lazy val line count equals task key, and then later on you have to sign it later. Instead of having an object is a Scala or extend Scala module, you have lazy val foo equals project.in.settings. Instead of having equals, you use colon equals. Instead of using something.something, you use compile / something. And each individual such mapping is trivial. But combined together, you get something that's not really Scala anymore. You don't define variables the same way. You don't override things the same way. You don't use super the same way. You don't stack traits the same way. And generally, although everything's there and it's normally in Scala syntax, SBT is pretty far away from Scala pseudocode. You do not write your Scala web backend with all these colon equals with comma-separated expressions. You do not define your variables by first saying a lazy val equals something and then using it later with a colon equals. You do not put your Scala doc in strings just so your runtime can use it. Like you put Scala doc in your Scala doc comments. Everyone does that. And that's what mil lets you do. So now we'll go into why mil is easy but not simple. And a lot of people I've talked to have said this. And it's true. Mil is not simple. It's very complicated. And we do lots of sketchy things in order to make this work. First, that T brackets thing that we do is a macro that expands into a new target with t.zip map with the original source file, all source files. It takes a value and it passes that in. So this turns your method definition into a free applicative. It's kind of like idiom brackets, if you've heard about that from Haskell. Like instead of doing 4, just you put your big brackets around it and then have some kind of marker inside. And when you actually evaluate the thing, it pulls them all out into a big applicative zip or zip map or app, whatever you want to call it. And this is what lets you create a data structure without explicitly constructing your data structure by hand. And that's why when you inspect things, you can see the inputs of each method from the command line. Like if this was just a normal method call, you couldn't do that. But with a bit of magic here, you can. You can also, now that you have a graph, you can also run graph operations. I want the shortest path from this operation, this operation. How does run depend on line count? Tell me. And it will say, well, run depends on run's class path, depends on local class path, depends on resources, depends on line counts. You can't run this in a normal Scala application. There's just kind of opaque methods, because opaque methods, after they compile, you lose all your metadata. But here we capture just enough to support this functionality. And if you want, you can inspect any of these to see their Scala doc, see what line they were defined in, and see anything else you want to know about them. Next, Scala doc. There's a Scala 2 compiler plugin that will then instantiate the presentation compiler, parse your whole Scala file, take all the Scala doc, and chuck them as annotations on all your methods. And then at runtime, use Java Reflect to look up the class hierarchy to find where the method's actually defined, and then grab the annotation at runtime, and that's how we can put the Scala doc into your command line message. And so next, we use implicit macros, not just macros and not just implicit, but implicit macros to put in your source code line and source code file name. As I said, source code is great for debugging information, see where on earth is this thing defined, where did it come from, where did it get called. And here we use it to add the file name and line number to your inspect message. Very handy. Next, we use another set of implicit macros to get the name of the object and the name of the method that you're defining. And that's how at runtime we can call foo.run. We have seen the foo string captured by this macro, and we can say, hey, okay, this foo refers to this object, this line count here refers to the method, and that's how we can kind of pick the right thing, even though at runtime normally on JVM method names and other things are kind of impenetrable. And we also use this for where to put things on disk. So you have object foo, where should source code be in foo.source. The output should be in out/foo, /whatever. Like for foo.line count, it goes in out/foo/line count. In this case, we write as JSON. Next, maybe it's not so interesting, we use a normal macro to generate the implicit read writer to let us serialize the values to JSON. That way, if you can't serialize it, at least get a compile time error rather than blowing up runtime. So in this case, the value is trivial, just a number, so we just get the integer to JSON serializer. So you look at all this stuff on the right, you look at the stuff on the left. The stuff on the right is not simple. It, in fact, is basically the same data structure any kind of graph execution engine will have internally. And the stuff on the left is even less simple because the stuff on the right got obfuscated by a whole bunch of implicits, macros, compiler plugins, Scala reflection, Java reflection, and some other things. But the point here is that if you take like a new intern and give them the stuff on the right and say, hey, can you help me make changes here? They probably will not be able to. Like, there's a lot of stuff here that they'll need to keep in sync, make sure they do it correctly, make sure everything lines up for it to work. If you give a new grad the thing on the left, they can probably fumble their way through and it'll probably more or less work at the end, more or less. So that's how Mill aims to make things easy rather than simple. Lastly, Mill aims to be fast and aims to help you be fast. So you can pass in this -j, which is like in make you have -- jobs, and it will run Mill in parallel, and it will print out a nice Chrome profile for you that you can load into your Chrome / tracing page. I don't know who here knows about Chrome tracing. Okay, so every browser, which I'm sure you all have Chrome, has a built-in performance profiler visualizer that you can use in order to visualize, like, where's my time going in this huge, concurrent, complicated system. So Bazel supports this, Mill supports this, and if you want to profile your own system in some ad hoc way and you don't write your own, you also can generate a Chrome profile.json that's loaded into Chrome. So here we can see I passed in parallelism of 6, and the bunch of stuff here is compiled in parallel. Here, this guy seems to be running sequentially for some reason, and here, this guy seems to be taking really long, Scala.lib.compile, and then after that, after Scala.lib finishes, bam, everything else compiles in parallel. So the point here is that in most build tools, the time taken is usually not in the build tool. The time taken is in the user code running within the framework of the build tool, and that's almost always going to dominate. So while Mill does put in a lot of effort to minimize the build tool overhead, it provides tools to try and make your builds fast, so build time does not become a problem. And your VP of engineering doesn't need to hear about why we need to prioritize build efficiency this quarter because slowing everyone down and making people quit. So that's the last of the agenda items. How we did a deep dive into how Mill uses Scala as executable pseudocode that's easy, boring, and fast in order to try and make builds great. That's why people don't complain about Mill, even though everyone complains about Bazel, SPT, Gradle, Maven, whatever. So some takeaway points. So as I said earlier, all of these projects are in the com.lihaoyi GitHub organization. We have like half a dozen maintainers. Any of them can commit. If anyone wants commit access, we are pretty free at giving it away. We need people to help. We need people to contribute, and we need people to like drive things forward. There's a Discord channel, com.lihaoyi on the Scala Discord you can use. If you want to learn about this in a more structured way, my book, Hands-on Scala Programming, basically walks through this example by example. Here's how you do this. And by the end of it, you have quite a big toolbox of how to do 143 different things using the com.lihaoyi libraries. So things like how do you write a parallel web crawl and make it asynchronous so you can pass your program in interviews? How do you write a multi-process system that interacts over pipes and JSON RPC? How do you write a programming language interpreter? So not just things like writing Fibonacci or writing linked lists. And all the code examples are online. So even if you ignore the book, don't want to read the book, you have 143 code examples of basically everything under the sun, all real projects that can do interesting things. Lastly, use a mill build tool. Like, I know a lot of people complain about SBT. There is an alternative. There's been an alternative for a while. You don't need to suffer. I have stopped suffering 5 years ago. It's great. You guys can stop suffering too. So next time you say, my SBT build is too slow, I can't update this, this is too confusing, take a look at mill. It is not confusing, it's fast and it's great, and people are happy. Okay, end of presentation. I can take questions.